Okay, here are the answers to the various group project questions for dimensional analysis. So the first one is how many inches are in 8 yards? So what you want to try to do is maybe set up the fractions with your units first and then fill in the actual conversions to make sure things are canceling the way you think they should. So if we have yards, for example, up here, then we want to make sure that we're doing some type of conversion that either does yards directly to inches if we have it, or we can go through any intermediate steps. Now we do happen to have a direct conversion. It's on your formula sheet and it's that 36 inches or 1 yard. So if I have it pre-set up, then I know that the yards are going to cancel and I have this written correctly. So now what I can do is go ahead and put in that I am converting 8 yards using the 36 inches and 1 yard formula. And the yards will cancel, leaving me with 8 times 36 inches, meaning that in 8 yards, there are 288 inches total. Okay. Same as if I go down here, you go skiing in Canada, there's a sign that says 100, but it's in kilometers per hour. So I'm going to write kilometers per hour. And our goal is we're trying to get miles per hour. So the hours are already fine. So we need to convert kilometers to hours. Sorry, kilometers to miles. And we do have a conversion for that. So we're starting with 100 kilometers per hour. And in order for kilometers to cancel, we need them on the bottom and we need miles on top. And if we do that without even putting the conversion in, then these cancel and I'm left with miles per hour. And now we can go look that there is 0.62 miles in 1 kilometer, which is 62 miles per hour, which is a little bit of a normal speed limit for us versus 100. Okay, going down to the jet planes with the Mach number. Okay, so if you have a Mach, the speed of sound is 344 meters per second. So I'm actually going to, write that up here as 344 meters in 1 second. So that looks like. And they're telling you Mach 2 is twice that speed. So Mach 3 is 3 times that speed. So they've written the actual conversion in the problem. And that's that 1 Mach is equal to 344 meters per second. So we've written that in. Okay, so grab that out there. So now when we're converting, we have a Mach 3, so we have 3 Mach. And we need to figure out, should Mach go on top or bottom? It should go on the bottom so that the Machs cancel. And 1 Mach is 344 meters per second. So I multiply those together because you're going triple the speed of sound. So you're actually going 1,032 meters per second, which is 3 times speed of sound. And that's what a Mach is. Okay, so now we want to know if your plane is going 2.5 Mach, how far is it going in kilometers per hour? Okay, so what we have off to the side is we have the Mach. We have that Mach number, and we can convert that Mach into meters per second. But then we're asked for kilometers per hour. Sorry, that was one a little crazy on me. We're asked for kilometers per hour. So our meters needs to go to kilometers, and our seconds needs to go to hours, and we're going to have to do whatever conversions we need to do. So it's a multi-step, and we're just going to go in order. So if I have a 2.5 Mach, the only conversion I have with Mach is that 1 Mach is 344 meters per second. Okay, that gets rid of the Mach, and I'm going to go ahead and just write what that is. So my 344 meters per second times that 2.5 gives me 860 meters per second. And I wrote it that way because now we're going to have to do a little bit of creative work here. So that's 860 meters in 1 second. Okay. Whichever order you do this in is up to you. I'm going to go meters to kilometers first. And then I'm going to go seconds to minutes. And then minutes to hours. And the reason I've set it up that way is because now I want to go through and make sure these cancel. So my meters cancel, my seconds cancel, and then my minutes cancel. So that leaves me with exactly what we wanted, which is kilometers per hour. So using all those cancellations, I end up getting kilometers per hour, which is exactly what we want. And now we're going to fill in these, and you can fill them in whichever one's easiest for you first. There's 60 minutes in an hour. There's 60 seconds in a minute. And then this kilometer one, there's 1,000 meters and 1 kilometer. And then to work this out, you go 860 times 1 times 60 times 60, and then divide by the 1,000. So that gives me a final number of 3,096 kilometers per hour. Okay. And then to do C, you work your way backwards, the exact steps we did in B, just backwards. So if I have 5,000 kilometers per hour, I need to convert the kilometers back to meters. I need to convert the hours back to seconds because meters per second is a Mach number. So we are going to work backwards. Any order you do these in is fine. Let's do the hours to minutes and then do minutes to seconds, getting me back the seconds I want, and then kilometers over meters. And then we'll pause there and kind of see where we're at. That means kilometers cancel, hours cancel, minutes cancel, and I'm back to meters per second. So let's put all those in and then we'll see where we are and regroup. So there's 1 hour and 60 minutes, 1 minute, 60 seconds, 1,000 meters, and 1 kilometer. So if you notice, we flipped all the conversions to go backwards. So that leaves me with a plane traveling 1,088.8 meters per second. And then a Mach number is 344 meters per second and 1 Mach. So we can go backwards. And just thinking of, does this make sense? 3,096 kilometers per hour was 2.5. This is going faster, and you end up with 4.03. So approximately a Mach 4 is how fast that one is going. So for this next one, we've spilled 4.9 million barrels of oil. Each barrel can be processed into 19 gallons of gas. So what you're getting in here is you're getting conversions. If they're not on the conversion sheet, they're going to be embedded in the problem. So 1 barrel is 19 gallons of gas. Cars get 20 miles to the gallon and drive about 12,000 miles a year. And we spilled somebody spilled 4.9 million barrels. So we're going to look at this one in 2 parts. And the first part is how much oil is spilled in terms of usable amounts, meaning gallons. Because we don't fuel cars in barrels, we fuel them in gallons. So let's first just look at the oil. So there were 4.9 million. So I'm going to write that out as actually the 4,900,000 barrels. And there are 19 gallons in a barrel. So that cancels my barrels. So there is a total of 93,100,000 gallons of gasoline. All right, now let's go do the car though. So what does a car take in a year in terms of gas? Because we're asking how many cars could this have fueled per year? So we need to know how much gas a car takes in 1 year. So a car goes 12,000 miles a year. Okay. Or 12,000 miles per one car is another way to look at it. Okay. And cars get 1 gallon for every 20 miles. Okay, so think about that just stepping backwards. If I need to go 12,000 miles and my car gets 20 miles to the gallon, I would divide those numbers to get how many gallons I'm going to have to put in my car. So I need 600 gallons per one car. And again, just try to step back from the problem a little bit and think if I need to go, 100 miles, my car gets 20 miles to the gallon, I'm going to do that division. Okay, then over here, let's finish it off. There were 93 million gallons, okay? And our conversion for a car is that it gets one car gets 600 gallons a year. So we end up with, we could have fueled a total of 155,166 cars for a year with what spilled. So if that doesn't quite make sense, think about it, walk through it again, kind of think about how you would do miles per gallon and whatnot with your car. So next we want to put 2 inches of topsoil on your 20 by 30 garden. We are sold topsoil in cubic yards. So think for a second how a garden works. Yes, you would fill it. Whoops. You would fill the, you would fill the area of it, but then you would also fill it in terms of that volume. So I want to put 2 inches thick of a layer, as well as fill the whole base, which is an area formula. So if I want to eventually fill this garden, which is 20 by 30, and then 2 inches tall, I'm looking at volume. And your other hint is this is cubic. Cubic is volume, squared is area. So the volume of this garden is going to be length times width times height. Doesn't matter which one you call length, width, height. But we're ending up with length is 20 feet, width is 30 feet, and height is 2 over 12 feet. Now 2 inches can't stay 2 inches. It had to be converted using the 12 inches as 1 foot because we can't just have these different measurements going. And then just leave that as a fraction because the math works out really well. It works out to be that you have 100 cubic feet that you need topsoil for. Okay, so what that ends up being is now we have that we can only buy it in cubic yards. Okay, so we have to convert 100 feet, 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 3 sets of units into cubic yards. So we have to do the conversion 3 times. So we have to do 3 feet is in 1 yard 3 different times. So 3 feet, 1 yard, 1 yard, 3 feet, or do the 100 divided by 27, which is 3 times 3 times 3. And the reason we're doing it 3 times is because we have 3 sets of feet. You can't just do it once. It's got to be feet divided by feet 3 times. So what that gives us is we have a total of 3.7 cubic yards that we need in the garden. Bags are sold as 3, so you would need a total of 2 bags to complete this. All right, and then last but not least, you have dosing says 2 milligrams per kilogram of weight. We have 1.5-year-old, which doesn't really matter, weighing 21 pounds, and we have it in milligrams per kilograms. So let's start with the child. The child is 21 pounds, and the unit of weight here is kilograms. So we need to come over and convert this into pounds per kilogram. Because that'll give us our kilograms. And our conversion is that 1 kilogram is 2.2 pounds. So this child weighs 9.5 kilograms. So then next, the conversion is you get 2 milligrams per kilograms of weight, and the child weighs 9.5 kilograms. So you would give a total of 19 milligrams of Benadryl. All right, that is the end of dimensional analysis.